All right, all yours, Garrett.
All right, I don't know if I need to use the microphone or not. I'll point it at me so we get both, the audio and the real audio and the fake audio. Thanks a lot. Welcome, everybody. I'm Garrett Wilson, and I want to thank NIMRED for letting me come. I'm so excited to show off this project. It's been under development for a long time. I also want to thank Matt for coming out. We actually got in touch. I guess you were in the area. I was in Rio at the time, Rio de Janeiro, Brazil, and we were answering things on Stack Overflow. I'm not going to tell you the subject yet because it's going to give away part of my presentation. But it was related, and I have to be presenting here, and he's here. I appreciate you coming out. And it looks like some excited, I talked to a few people, looks like you're excited about Java, so I'm excited to present this tonight. A little bit about me. My company, Global Mentor, is the consulting company that I do software development work for, mostly in the Bay Area right now. My clients right now are in the biotech field, but I created Global Mentor originally to create software in the education field. Education is sort of a passion of mine, and it got started creating ebook specifications, but unfortunately this was long before anybody knew what ebooks were and before anybody wanted to use ebooks. However, I did get the chance to work with some people at Microsoft, Nokia, Nuvo Media, which I don't think exists anymore, and a few other companies to create a specification on storing ebook information. We called it the Open eBook Publication Structure, which has since been named to EPUB. You've probably heard of that. So that's the newer versions. I was involved only in the original ones. But since then, continuing to develop educational software separate from my consulting, and I've created an entire course on software development. We've got some students going through it right now. So I'm interested in education. So when we're finished talking to this offline, if anybody wants to talk about education and students, that's an interesting topic to me as well. In fact, one of the implementations of this, one of my students, we'll get to it toward the end of the presentation, created one of the implementations for this, and I just tried it out this afternoon, and it works great. So I put it to Maven Central, and if we're lucky, it'll be visible by the end of this presentation. So before I get started, I want to get an idea of who I'm talking to tonight. Java, everybody has been involved with Java. About how long? Who's been involved with Java over 5 years? Wow. That's going to be great. It's great to talk to people who know what I'm talking about, and who, if I talk about something that we only recently got in Java, or it came in this version, and you guys will know what I'm talking about. That's good. And NIMRED.
I was going to mention that the group's actually about 21 or 22 years old.
Oh.
How many user group?
Oh wow. Okay. That's excellent. And web services. That's the next thing. Internet programming. JSON. Who pronounces it JSON? Who pronounces it Jason? JSON? And Jason. All right. Well, good. It's one of those words that when you talk, you just read it, you don't know how to pronounce it. So I've always called it JSON. So it's good to know that I was right. Toward the end of the presentation, somebody asked, "Why did you create a new format?" And I'll get to that toward the end of the presentation. Let's talk a little bit about what it is. Again, my company is Global Mentor. If you want to take this, if you got any questions, Surf right now is completely developed by Global Mentor, and eventually, though, we want everybody in the world working on it. We'll see how successful that is, but I'm very motivated and committed to it. So if you want to talk to me right now, the email to take down is info@globalmentor.com. So the presentation tonight is on the Surf format. It's a replacement for JSON with rich, readable data interchange. And here, the website, as you know, launched about a week ago. You can go here and see the website, and we'll go there in a second. But what is Surf? It means simple Earth. Okay, that really helps. What is IRF? IRF is the Uniform Resource Framework. Well, it's getting murkier and murkier. Let me talk a little bit about what SURF does. It serializes resources. And now we got another word thrown in there. We got objects, now we got resources. There's 3 types of serializations in SURF. Literals, objects, and collections. Now at this point you're like saying, wait a second, why do we need this thing? Don't we already have JSON? And isn't it already simple and easy? Isn't it good enough? Why do we even need to start talking about these 3 categories of serializations and stuff? So let's take a step back and look at JSON and see what we got. And not step in this hole here while I pace back and forth. Hide that. So it's pretty simple. You've got name is Jane Doe, an ID, that's a good or UUID, an email, phone, aliases. You know, they got 2 different aliases that they log in as, I guess. Their home page, when they joined, balance, let's say that's their credit balance of whatever money, I guess. Charge, their monthly charge. I don't want to trick anybody. Please look at this and let me know, is there anything weird about this? I mean, this is something that you would probably, in a real web service, this is not unusual, right? This is typical. I'm not throwing anything weird up here, I'm just trying to say. I mean, last week I created stuff that sent stuff back using Angular and JaxRS in the background. It looked like this. So there's nothing weird here. So, and it works, right? So, why do we need anything else? Matt might want to know, might have an opinion, or I might know where I'm going with this actually. Dates, okay, I'm picking easy things here, right? You probably could think that this might be coming. This is a quote from Wikipedia. As of 2011, no really, I pulled this up 2 days ago. As of 2011, which was 6 years ago, there are some de facto standards, for example, converting from date to string, but none universally recognized. No, really, in 6 years, we haven't found a standard way to put dates in JSON. Dates in the wild. Let's look at a few of them. Matt probably recognizes, Matt works a lot with .NET, and plus he's our date expert here. Done a lot of stuff in Moment.js and some other things. He probably recognized the first top 2 because he worked a lot in .NET. I think those are .NET representations with 2 different ways.
On behalf of Microsoft, I'm sorry.
You know, I read a blog entry. It's some sort of cool thing that you do because JSON says that you can actually escape the / even though you don't need to. So nobody does. Except they decide, well, we'll escape it to say that it's a date. And then, of course, you know, the third one, which is ISO 8601. Well, one of the gazillion formats of ISO 8601. And then, I think what the last one was, I got that from Bertrand Leroy. I was just sort of looking around real quick. And he uses, what he used to use was it's just, you know, the number of milliseconds since the epoch, sometime in 1970. And he puts little @ signs around it, which is sort of cute. So, we at least would like a way to put dates in JSON. Well, but there's still strings, right? So how do you really know that that's a date? You got to know ahead of time, right? You got to have some other specification for knowing that. But really, this is just one type of date. It's actually a fixed date time with UTC. It's not a local date. So let's say that, you know, you want to talk about a particular Christmas. You don't want to talk about Christmas at a time in UTC because it happens on the same day around the world, but it could happen in different instances. I'm not going to re-explain the whole Java time library. Times. These are not even if we get a date standard, we still have to represent times. Oh, durations. So this is like the 1/15th of a battle solving this, and JSON doesn't even have this solved. Well, okay, surf. I forgot to tell you that first thing you saw, the JSON document, it's also a valid surf document, so you can parse it as surf. But you can do so much better. Look what I did, the little highlighted part. I took the quotes off, and I put an @ sign in front of it. The @ sign means at this date, or at this time. So if you want to represent a time, look, this is not even an instant. It's actually we call it a local date in Java. And a lot of people call it a local date as well. It's a year, month, and a date, irrespective of any particular time zone or any time. So that's the first step. At least you know now that surf buys you something. It's an easy way to do dates. In fact, surf likes dates. We've got over a dozen types, and they're all the standard things you could recognize, except that this is, Matt and I talked about this. We're probably going to go with the way Java did it because nobody else has said a better way. ISO 8601 does not have a way to specify an absolute date and time indicating the time zone. It does with zone offsets, but zone offsets and time zones are two different things, and that's another conversation which we could have a 30 minutes on. There's so many ways we can go down the road, so I'll try to. If you got questions, by the way, if you have any questions while I'm doing this, let me know. Some of these could wind up 100 questions, and we'll try not to go too far down, but definitely stop me if you got any questions. So these are all sorts of dates that you can do, that you can put into a surf document. And it's going to know it's a date, it's going to know it's a time, and the thing about it is suddenly you're semantically encoding data. It's going to flow from Python to JavaScript to Java, and you're not going to lose information or have to say, oh, are we using the escaped / to tell us whatever, or was this a date, or was it just a cool string with an @ sign in front of it? No, it's actually a temporal type in surf. Yeah.
So your second one there, which is somewhat similar to the zoned offset of ISO 8601 up there.
Yeah.
In ISO 8601, that time is already the local time, which basically makes it non-sortable. And so where I'm going with this is that I talked to one of the GitHub developers, and they've come up with a slightly modified form. They put the Z followed by the zone offset, so that it then sorts.
Oh, you mean this, the lexical representation sorts? In other words, the string version of this sorts. Oh, I got you. Like not like naming your file names starting with ISO 8601 version so that they sort by time. And so if you got a bunch of file names, you put it in ISO 8601
At the
form
front.
so that the file name sorts. The same concept you're saying.
Right. Which is
No, I'd love to talk to you more. So surf. By the way, I didn't mention I've been developing this for a few years. I'll get to the story later, but it's the first version of this was 2007, so it's been 10 years waiting. So I'm glad that you told me not to move the time numerat. So I'm like, okay, this will be an incentive to go ahead and say we've got to put it out there. So the point is, it's not to version 1.0 yet. We've got the reference implementation of it out. So little modifications like this, if you have a better idea, we can, by all means, let's discuss it. In fact, I met Matt, we were talking about this exact thing, the best way to represent the time zone in the string. So I'll send you the stack
over years.
Yeah, we got lots of stuff to talk about over beers. Good thing I'm not flying back till tomorrow. Okay, so we got dates out of the way, right? But everything else is okay, right? It looks fine. The numbers, I mean, how can you screw up numbers? How can you screw up scrambled eggs? I can't cook, and I can do scrambled eggs. I mean, just a microwave in a bowl, right? Okay, so let's try it out. Here's a JSON document up top. It's a part of what I showed you earlier. Here's the balance, right? 0.90. Here's the charge. So, and this is the Java users group. So let's read that JSON document, and this is This is very straightforward. Again, I'm not, are there any, okay, I am trying to trick you, but this is not out of the ordinary, right? Any questions? Yeah.
But you did choose to map the fields to a double rather than a big decimal.
No, this is JSON. The point is, let's say in Java that you mapped it to a double. What's going to happen, or I'm sorry, a big decimal. Let's say that's like that in Java. You serialize it to JSON, and it goes to your JavaScript, and it comes back to you. Are they using big double on the server in JavaScript? Or in Python? No, they're all using, well, I'll get to it in a second. So the point is, even if you take care of business in Java, once you get it to JSON, there's nothing about JSON that says it's got to be a big decimal. So if it goes to Python, it comes back to you, it's going to go from a big decimal to IEEE 7, whatever it is, because it comes back to you. We'll get to that in just a second. But no, good point, and you know where I'm going with part of this. So if I run this look, how much more simple could this be? I start at 90 cents, and charge at 30. 90% of you know exactly what I'm talking about here. While the balance is not zero, I subtract the charge. So every month I'm going to charge 30 cents. So what's this going to print out? Well, it's going to subtract 30, it's going to say 60 cents, and it's going to say 30 cents, and it's going to say 0, and it's going to stop charging, right? Yeah, funny, if only. Yeah, that's what it shows in Java, and it's what it shows in Python, and it's what it shows, well, Python, there's a big, if you read there's big long, over the versions 2 and 3, how they decide to manipulate the floating point format to show different printings, because, as you know, certain numbers are only estimates in, this is all about IEEE 754, and it's what all major languages use to store floating point values. And there are some values, not even weird, a lot of people think, oh, it's about how many digits you have after the decimal. No, 0.3. You cannot store 0.3 exactly in a floating point number because it's certain numbers, it simply stores an estimate of that. And so you don't ever, nobody here probably makes this mistake because you've been doing Java for so long, but for the newbies, people in my class, one of the first things they learn, like the primitive types, don't ever, 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 ever store money in floating point types, even if you're in JavaScript, Python, Java, or whatever. But that's all JSON has, is the one number type, which, you know, and who says that all your, for example, back, what was your name, sorry?
Eric?
Eric. As Eric mentioned, you can store it in a big decimal. But who says your JSON parser is going to put that in a big decimal before it gives it to you? You have to create your own, your own parser or whatever. So there's lots of gotchas. The point is that the data is coming from JSON, all bets are off until you get it into some data model in Java. So what do? Do you put your money in strings? Back to the date thing, right? So now we got the whole JSON document are just strings. So we throw out dates, throw out numbers, and everything just a string now. We might as well put true and false in strings. And the thing I say in my classes is, before you learn about big decimal stuff, you really store cents in a long or something, and then at the time of display, you convert to some display format. But Surf has a decimal type. As you know, Java has a big decimal type. Well, C# also has a decimal type. Python has a decimal type. Ruby has a decimal type. All these languages have a decimal type, but they have no way to send decimal numbers back and forth to each other. I think in .NET, don't they use M, I think, to represent the, I just read it, I haven't used it, but I read it.
It's for the literal representation.
Yeah, and, the literal, you type the number and you put M because, I guess it stands for money, right? But that's what I guessed. Even though, really, it's not a money type. So this is not a money type, it's just a decimal type, which you can use for money. And so, the way you do that is simply, how hard is this to remember? Again, over 10 years, there's been a lot of thought into what delimiters I use. So, if you want to make this into decimal type, just put a $sign in front of it. And so, on each of those platforms, the specification says that your parser must maintain correct addition and subtraction and arithmetic as you would expect with a decimal type, regardless of whether you're on Java, JavaScript, Python, or whatever. So suddenly the specification guarantees this that you're going to get round trip fidelity. Yeah, Eric.
Why not make all numbers decimal by default?
Oh, well.
And if someone wants to have some high performance optimization and they know what they're doing, they can always cast it to double.
There are probably some math people that would have a better answer than me, but I would imagine there's so many scientific calculations and stuff that are optimized for floating point, and plus a lot of, I'm sure that, if all numbers in big decimal, for example, you got all the object overhead. If you're in the scientific community, you've got a lot of numbers. For example, in the genetics community, for example, microarrays. You've got all these different things on a plate, and you run it through hybridization, and you scan it, and you're measuring the intensity of each level to find out whether or not there was a mutation in that area. The intensity level, there's going to be a lot of numbers. The intensity level does not need to be exact. So your floating point's fine for things like that. But I think the calculations in floating point probably are going to be a lot quicker. It's built into the CPU, right? And you're not going to have an object overhead for each one of those.
Well, clearly if you're sending around JSON data, performance can't be such a big consideration.
Well, you got to. The point is that you got to communicate it some way. So the specification, the CERF specification says you got to maintain fidelity for the decimal types. So you can't. So it guarantees round trip fidelity of the exact value. So you're always going to get a 0.3 and not something else. But to answer your original question, I think there is still some need to say, this is a number you can represent as floating point. It's okay to do that. I think there's going to be some value to that.
Question,
Yeah.
so does that dollar sign represent currency, the US dollar?
No, it's not. It does not represent currency.
Okay.
It's simply a convenient delimiter to help you remember that this is the decimal type. You'll probably want to use it for money, but it's simply what you use to use it just as we used it, an at sign to represent a date, because you can think, oh, it's at this date, or at this date and time.
Why not use British pound instead of a dollar sign?
It's not asking. One of the design considerations for this, surprised I had an answer. No, I did go through a lot of these because there's actually, even better than that, there's a currency symbol. It's a little round circle, little things that looks like a little alien or something. It's not asked. One of the design considerations of this, through the long evolution of, before there was surf, there was turf. I'll tell you about that in a second. I promise you. Before I even thought of this, but that's why surf is the simplified version. The original version, I had all these cool delimiters going on, and then I realized once JSON became ubiquitous, there is a value. Still yet, even though we support Unicode, there is some value in the delimiters being able to type them on the keyboard really fast and going in to edit your config file, and I have to hunt around for the British pound sign or something like that. So one of the design restrictions for surf was to have all the delimiters ASCII. Turf does not have that limitation. We'll get to turf in a second. I'm going to put this up here in a second. Good time. All right, there we go. So surf has lots of types. Well, I'm going to go through each one of them. I mean, I won't go into depth, but I'll at least show you some of them. Regular expressions. That's a separate type. It's not a string. You say, oh, I have to remember this string is regular expression. You actually have a type regular expression. And it looks just like, the interesting thing, JavaScript, this is the literal representation of a regular expression. So it's nothing new. And it's sort of interesting that JSON didn't have exactly this, because it's what you have in JavaScript. We have IRIs. We're all new and fancy. We don't just have we don't just have URIs, and we certainly don't have URLs. We have IRIs. Sorry. So the internationalized form, and that's. I think on my third beer we can start talking about the differences among those. But basically, you all know what a URI is, and we just support internationalized characters, as all the new standards say they do. Goods, UUIDs, that's your own type, because you really put those in a lot of JSON files probably. They're so easy to use nowadays, we assign them to new things we create. So if we're going to be storing them, sending them back and forth in web services, we might as well have their own type as well, so you won't have to remember which strings are goods and which strings are not. The ampersand symbol, that's the delimiter. You can sort of think, if people who've used C, C++, you could think of sort of that's the address of, and it's, okay, it's a little reach there, but you can think of that GUID as like the address of your object. Okay, it's sort of a reach, but that's the way to remember it. Email addresses, yeah, it's its own type as well. And if you pull out your phone and send an email to somebody, you're probably going to get a little button that has a little paper airplane, right? Maybe like Twitter. If it's even look, you've got there it is, the little airplane. That's an email address. Yeah, all this is specified in the surf specification. Reference all the RFCs and stuff. You mentioned RFC on the conversation, the Stack Overflow. Yeah, it's all. We talk about which parts of which part of the production of whichever thing. So it's rigorously specified. It's not just, oh, put an email address in there and then one day somebody decides to put quoted whatever in there. And well, it's a valid email address. So we specify the surf, and we got the surf specification. And got a lot of, an entire set of test documents so that when people implement these in other languages, this surf in other languages, they can turn off Slack. It's in Portuguese, nobody understood it anyway, right? Hopefully, we turn it off. Quit. There we go. There's always something that pops up. Phone numbers. You should remember what the delimiter for phone numbers are. Yeah, they're their own separate type as well. And I didn't even have to think hard about that one because it is the actual ITU and its various other specifications. The global international telephone format is a plus sign, and then the country code, so on and so forth. So we support telephone numbers. Surf also supports binary values. As you might guess, this is base 64, and you probably, if you pass binary strings, maybe you want to embed an icon in your JSON. You probably send it as a string. It's base 64. And then the other end has to know that that's actually a bunch of bytes code base 64. Well, we decided binary is like ones and zeros. So we found a symbol here that has 0, 1, 0, but with the one sort of leaning. But so that's the delimiter for binary, and then you just put the base 64 right after it. Nothing complicated. This is why it's called simple. But a lot of thought went into trying to make it simple. So these are all types, so you can put them in. Let's go back to the original JSON document, which was actually a surf document as well. We just tidied it up. Look, instead of all those strings, we've got a GUID. Our parser is going to know it's an email address, a date. It's going to know that that's a URI, an IRI, and that those are decimal types. We took something that's typical you use every day, and we suddenly made it rich with types. Any questions at this point? Yeah, Eric.
One limitation with numbers in JSON is I think you can't represent an infinity or not a number.
The NAND and stuff?
Yeah. So is that something you addressed with the...
It's not. Some of these things we've got to be careful with because you can open up a box of worms or a can of Pandora's can or mixing metaphors. You can really get yourself in a, for example, null. As of now, and I know some people won't like this, Surf does not support null. Semantic frameworks, the whole idea of null, you know it's a problem just by the fact that the whole get a value from the map. I get a value from the map, it's null. Oh, does that mean the key value pair was not there? Or does it mean null was associated with the key? So you got run into all sorts of problems. If you talk to CJ Date, who is basically COD's successor and the current expert on relational databases, he can go on for several books, and he does, about why null should never exist. So right now, null is not supported. It actually, so supports all parsing all JSON documents, so we'll read null, but we'll ignore anything that was where null existed. So for example, if you got an object, the property is null, we'll just throw away that property. So I mean, there's a semantic debate about if the property's, if the property set to null, does that mean there is no such property or set to null? That's over, how many beers are we now? That's the fourth or fifth beer when we talk about the semantics of whether a property does not exist or whether it exists and is set to null.
It sounds more like an implementation detail of what you're doing with the surf data rather than the surf format itself. Though. Like, if I have a property in my object graph and I've got a null in the document, you're not populating, well, I'm going to get a null. Right?
But you're thinking still in syntax terms, and the secret of surf is that underlying surf, there's a semantic layer, and we'll get to that in about 70% of the way through that. So null is tricky. So as of right now, surf does not support it. I don't think it's a big impediment, but we can certainly discuss that. Yeah. What name, by the way?
George.
George.
So my question is on the question of nulls is what about for in lists of primitives?
Oh, good idea. We need to talk about that. I don't have as fast a question as I had to Aiden, right, earlier. Yeah, no, that's a good thing we need to clear up. So that's before the 1.0 of the specification. Good question.
Sorry, separate question. Out of all the types you've shown in the doc, most of them, all of them except email and phone number tend to line up with things I would expect to see as types in most languages.
Yeah.
Most languages don't have a dedicated email type or phone number type.
Right.
So if I'm in some random language that doesn't have an email type or a phone number type, and I come across one of these, do you expect the person to provide one somehow?
Well, see, you don't just come across them in the language, you come across them through a parser, right?
Right, the parser would see
So the
this
parser
syntax
is
and would have to fill
required,
it with an email type or something.
right, and so the parser is required to do that. And it's required to not lose any semantics. But that's just as easy as simply creating a wraparound string and calling it an email type.
I guess I'm just curious why you picked email and phone number. I mean, you could do the same for color,
Well,
for example, for artists.
Well, unless you stop and think just a second, you probably have several email addresses and phone numbers, and they're used for identifiers. That's what we use for communication. And so I don't give you my color, call my color sometimes. Yeah, so the point is, information. It's just so essential, and I thought it'd be cool to throw in. But I think that it is so essential. It's stuff that, for example, the V-card specification, which trying to, back when we were doing ebooks, they were still trying to shove that into RDF. That's another long story. But addresses. One of the big things of your address is, beside your address is your phone number, and an email address as we use it for basically. Data a lot of times isn't useful unless it's identified what it is, and those are two of the biggest identifiers. So I felt that they were going to show up all the time, and if we didn't include them, people would be coming up with their own mechanisms to specifications on top of this format to say which things are going to, for my application, are going to be email addresses and phone number, and then coming back and forth between string and some upper level type if I didn't include it.
I think his question is leading to, do you have anything for user timeframes?
Maybe the next slide. I love it when people just me. Yes. We'll get to that in a second. Oh, since, and I know Gamble is already here doing this sort of thing, but you don't need comments. How many times have you been editing a JSON document and you run your program and it's like, we expected something like, what do you mean you expect? And you go back, oh, I left a comma out, right? Well, if you have new lines in what's Surf calls sequences, which are lists, map entries, set entries, things like that. If you have new lines, you don't need comments, so they're optional. And it makes it a lot easier to edit. So we start with the same JSON document, and it's just easy to, it's suddenly richer with types, it's easy to edit. However, if you do want to send it across the wire, you may want to stick the commas in, just like JSON. It becomes very small and almost like binary, but you can still pick out what's going on. Or just click format, it'll reformat. Unless we get the search formatters. Not this week, maybe next.
Can you go back to the previous slide?
I can figure out how to, there we go.
So, do you need the quotation marks as well, or is it?
I'm glad you brought that up. You do, in this case here, but I'll get to that in just a second. Thanks. Good. I'm glad you guys we're all going the same path here. May not like where I end up, but at least we're going in the same direction. So you can do it compact with commas, or you can throw it out. You might have even forgotten to ask about comments since JSON doesn't have them, but it's sometimes useful. It's a little exclamation mark. There's so many variations. I'm not the only person, Surf is not the only thing using exclamation marks. I think they're usable in INI files maybe, along with the hash sign. But I can give you various justifications on how that's meaningful. But that is Surf's delimiter for comments, the exclamation mark. So here I noted it's the current account balance, indicating what that was. And the comments work just like they do in any other language, or markup. So another thing about JSON that you probably already knew was that JSON objects aren't really objects. What they are, they're actually maps, or associative arrays. But maps are easy to say. So all we were describing here is really not an object per se. You were describing a map. So everything you pass around in JSON and say it's an object, it's really a map. Except that JSON doesn't even let you do a complete map. And by the way, JSON is, let me make clear, JSON has done a great job. It's very useful. And when I say the way Surf is better than JSON, I'm not trying to say that whoever invented JSON did a horrible job, or he's a bad person, or stupid, or whatever. I'm simply saying that it brought a lot of good things, and I want to make something even better because we progress and make things better. So at a certain point, I think a lot of things become stale, and you gotta move on. So at this point, we need something with dates. We need something with decimal type, and if we want to map, we want to put something besides strings in the keys. See, this is a map, but JSON does not let you put anything except strings as the keys in your map. And in your software, you probably use other things as keys in the map. Maybe telephone numbers? Goods? Yeah, JSON only allows strings for map keys. So let's get into some new things in Surf. Surf has real objects. So we'll get away from maps just a second. This is a Surf object. It's a little asterisk. And if you, back in the C++ days, you can think of it's like an instance of operator, right? No, what was it? It's been so long. It's the
dereference.
Dereference, that's what it is. The opposite of the ampersand, right? Well, you can think of it as sort of like the instance of sort of Big Bang. It explodes into existence. I'm reaching, but trying to associate this in your mind. That's the instance of, that's an object. Think object instance. Now, Surf objects can have real property assignments. As I told you in JSON, the quote-unquote property assignments are really just map associations. In Surf, your objects, which are separate from maps, actually have properties. So you notice I don't have quotes around the name. What I did is I said here, let's go back, and I said this is an instance of some object, and the colon says I'm going to describe that object. And then I have properties, and instead of colon, it's an equal sign, saying that this property is equal to that. So you're actually describing aspects of some object instance. For example, this shoe, just off the top of my head, this shoe, its color is brown, right? I'm not saying that this color is a lookup thing in a map that it gives you the brown. I'm saying it's a property of this thing, which semantically means something different. And you can make semantic inferences with propositional logic, but we'll get to that later on. So this looks similar to JSON objects, but they're actually real objects in Surf. You can give them types. So this little instance of, or the object thing, before you put the colon, you can put a type name in there. As long as you follow the type names, the type syntax restrictions for Surf, you can put any object, any type name in there you want. You make it up. There's no big intricate rules about what the type has to be and stuff. It's a string, and you let it mean whatever you want it to be. So that's why it's simple. We're not trying to jump to some object registry or something, or compile it. Put any string you want in there, and that's going to be the type. So now suddenly we know something you can't know in JSON. We're saying that this is an object. The name of this object is a string Jane Doe, and the type of this object is user.
So the name is not necessarily restricted by the language the parser is parsing to?
What name? The name property here?
Yeah, so the certain, the actual user, for example, type. I'm just thinking ahead, when you're parsing this and you're actually creating an object in Java.
Yeah.
There's some restrictions to what that object should be called. And so I'm wondering, the person implementing or writing is defining this object should be.
Well, so you're assuming that what it's going to give you in Java, the parser is going to give you, is going to be an instance. You'll be able to say instance of user in Java, and that's not the case. You will get something that says, I'm representing an object from Surf. You can ask it what its type is and stuff. Not necessarily that it's going to be a native implementation in Java of some class called user. This is only in the Surf, so the information will come back to you. It may not be that this type as a Java class, for instance. That, everybody understand the question and the answer? Okay. But it's still useful to represent this stuff, because you may put a layer on top of your parser that says, I want to serialize my objects using this. Right now, I think they even they've tried to put this on top of JSON so that certain things mean the type, and this maps to a Java class or something. So this, in Surf, it actually means this is the type of the object. So you can sort of read this as follows. An instance of user described as follows. Name, JDoe, so on and so forth. So in Surf, you've got to have a little asterisk for every object. We'll talk later about why that is. Sure. So there's another format, which is the Uber format on top of Surf. It's a superset of Surf. And it will allow you to leave the asterisk off, but that means you would be describing the user type itself. So to prevent confusion, Surf does not allow you to do that. So here's where we come to. Yeah, question.
Yeah, so the moment was kind of put in the types, the definition of the type changes over time. So the user later might get the name replaced by a full name or a given name.
Yeah.
So I'm wondering, does it make more sense to put the type inside of the object and maybe allow for extra information associated with the type itself?
Are you saying that the object would change its type?
No, the type is still user.
Uh-huh.
But let's say today the user only has a name and email address.
Mm-hmm.
Then later say, oh shit, I forgot about ICQs or whatever
Yeah.
the next communication format is. So I will add the things and say, oh, it's not a name, it should be a full name, and I will have a given name and a first name.
Well, so surf on its own doesn't make any restrictions. So you can, the parser doesn't, just a normal surf parser doesn't, you could put a foo in there and it wouldn't care, just like JSON.
What he's driving at is how do you represent metadata about an object, adding things like a version number.
I didn't plan either of you two, okay? I promise I will address this in a couple of slides. I'm glad you're interested in that sort of thing. Because that is the one, actually that question came up before surf existed. That was the question that drove the creation of the uniform resource framework that underlies it. So if you don't mind waiting a few more slides, I will address that. And that is one of the values. A lot of people say, oh, it's just another syntax. You got YAML, you got JSON, you got XML, just different syntaxes. But it's this reason exactly that underlies it which makes it different. Surf is not just a syntax, it's a syntax for an underlying object model. So that allows you to do exactly that. So let me get the easy stuff out of the way that everybody is interested in, and we'll dive down as deep into that sort of thing.
Question, are we talking about schema evolution here?
Yeah, it's that sort of thing.
Okay.
Yeah. Or even the fact that you have a schema to say what is inside of what. Yeah. So I will address that. But I want to get to the main point that everybody sort of, because maybe not, if everybody's interested in this sort of thing, I would love it, but maybe not everybody is. So here's where we came from. We started with that JSON object, which really was an object, was a map. Here's what it looks like in Surf. I've tried to make this so that it's not a lot more complicated than what you started out with. I mean, I think, now sometimes when you're developing something, you get so close to it that it looks plain as day to you, but to everybody else is like, what is it? But I think this is as plain, or maybe almost plainer in some ways, because you don't have all those comments in there, as what we started out with. But I think we've gained a lot more semantics. We have type safety for all these different types. We have a real object, and we know that it's of type user. And we just changed some delimiters here. We've got a colon to introduce the description of the object, and a semicolon at the end. Once you use it for a few days, you'll be used to that. So this is the Surf version of what we started out with. And I think just, writing your whole layers of translating these types and such on back and forth, there's just so much time and resource involved in coming up with a way to do those things for dates and phone numbers and such. This way it's built into the parser, and plus it's a lot less brittle, and it's a lot less error prone than just writing your own. It's built into the Surf parser.
So I want to ask about that too, because at Amazon we spent the better part of half a year rewriting one of our parsers because they were so disastrously written that it was inefficient as hell. And that was an implementation detail that ended up having massive effects across the company. The parsers, how do they compare performance-wise for Surf? What language are they available in? And how extensible or modifiable are they?
I'll answer some of those questions when I get to the reference implementation. The part about, let me address two of those right now. The one about the, two or three things I wanted to say, and I started one and I forgot the other one. Surf comes with a large database of, a large set of test files, a test suite. And so it's not just looking at the specification and writing a parser. There's going to be a lot of files with all sorts of little tricks. Just like when XML came out, the person who named it, I forget his name, it was back in 98 or so, he put out a whole, somebody, he put out a whole test suite, so all the new parsers they would run through, and they would, just like CSS, you've got these CSS tests that show you how much that, how close you are to meeting. I remember when XML first came out, Microsoft parsers in IE, they wouldn't even put the slashes correctly on the closing tags stuff. But you got to admit, nowadays, because of well-written specifications and because of test suites, you can pretty much rely on XML parsers. So that's what we're trying to do here with Surf. We've got a specification that, based on the experience with ECMAScript, with JSON and other specifications, in my experience in helping write the original EPUB format, the specification is going to be clear and doesn't allow leeway. And as well, the test suite will allow people to make sure that they that they're really working. As far as efficiency, of course, some of these won't be as fast as a JSON parser because there's more information here. On the other hand, if you calculate in all the time that you're spending in your code after you get the JSON document back to translate from strings to dates, to translate GUIDs and phone numbers, having this built into the parser is going to be much more efficient if you measure the whole, from the information in the file to your data model. It's going to be a lot faster. Sure, this may not be quite as fast as a JSON parser because it's looking at more things, but to get your data model, JSON is only part of the way there. And I'll answer the other question about availability in a second. The last thing I want to talk about as far as the basic surf stuff is collections. And you already know most of this, if you didn't know it. Basically, when you parse a surf document, these collection types will map directly to your language implementation. So if you parse it in Java, if you have a list of things, you're not going to get array, you're going to get an actual implementation of the collection framework list interface. But that's important, I'll get to it in just a second. Oh, and it's a perfect fit for the Java collection types. Even JavaScript, ECMAScript, as of 6, I think, now we're on 7, but the 6, I think it was, JavaScript even has these collection types. They have maps, they have sets, but you can't take advantage of those in JSON, because when you have a map in JSON, as I told you, it's really map, you get an object thing back. And there is no set in JSON. But in Surf, you've got all 3 types. You've got a list, just like you've seen before, an array in JSON. Works just the same way. You have maps in Surf. They look just like maps or objects in JSON, except you can put anything you want as the key, any type. Just like you would your language. Why should your serialization syntax restrict you on that? Yeah?
So can the key be an object,
It can.
like a person?
Sure.
How would that look like?
Well, if you were to, for example, to copy everything here and put it in the place of that 5, later on I can actually bring out an editor and make one for you. But the nesting and stuff works just like JSON.
Is that a good idea?
Well, that's up to your implementation. There's a lot of things in life that whether they're a good or bad idea depend greatly upon the circumstances.
Well, would you have a shortcut, sort of like a reference to that object that you could use instead?
I promise I didn't plan all these people. I'll give that like 2 slides. I love it. Thank you for asking these questions that lead right up to this. Here's this. So what was your name, by the way?
Dan.
Dan, okay. Yeah, we do have references, and I'll show you one in a second. Sets. We have sets. They're these things, parentheses. And it's just as you'd expect. They throw out the duplicates, and they would show up in Java as an instance of the set interface. And in JavaScript, they would show up as an instance of an ECMAScript 6 set, just as you expect. So the point is, JSON just hasn't kept its like set in stone a few years ago, you know. So Surf allows you to use your programming languages alongside your serialization format as you would expect. So my point here is that for a list of aliases, it's really a set of aliases. You wouldn't have duplicate aliases, and the order doesn't matter. So this semantically makes more sense. So thank you, Surf. Dan, back to you. Reference resources with Surf labels. I mentioned on like the second slide that everything Surf represents is called a resource. It's just a bigger term for everything, the things it represents. So you remember that we have collections, we've got literals, and we've got objects. Instead of calling everything an object, since object is a special syntax, everything's called a resource. That's what the resource description framework for the W3C does as well, which we can talk about that later as well. How am I doing on time here? 8 o'clock, so. Okay, cool. Yeah, I'm doing great then. So thanks for the question, Dan. If you were to create a label for anything, just imagine a square label with something written on it. Put a little bar on each side of that name and stick it in front of the object you want to reference. So imagine we have an object of type game. It's a game object. And again, the type, you could have left this out if you just want a bare object, but I think it gives value to say that this object is of type game, okay? It's got two properties. One is a list of players, and one is a winner. So the list of players has two objects here. One is a user with name Jane Doe. Other one is a user with a name of John Smith. Now the winner happens to be Jane Doe. Instead of copying this user down here, as you mentioned, we want to say, this is something JSON can't do. You can do it. There are specifications that try to say, well, we'll use certain identifiers to mean that it references something else. And in XML, you've got these certain specifications that we're going to use refs, ID refs, things like that. IDs and ID refs, right? But then you have to have something that understands that specification on top of XML. This is built into Surf, and it's real simple. All you do, if you got something you want to refer to later, just put a label in front of it. Here I use the word Doe. Use anything you want, and it's only for the document. It disappears when you parse it. It's simply a way of linking things up. And so here, instead of copying that user, we simply put a reference there. We put the same label, and it references it. Yeah?
So you say reference an existing instance. Does order matter in this?
In Surf, it does. To make this as simple as possible, you can't have a reference to something that hasn't been serialized yet. So we don't want several passes going on. We also don't want something, because nobody's going to adopt this if you got to spend 6 months writing a parser for it, right? And also, I think this approach takes care of a lot of use cases. So you can't have something where you put a label on one object, and then down here you use the same label and add more properties to it, you know? You can't do that in Surf either. However, you will be able to in Turf. Turf is the complicated or Surf. It's as simple as the complicated one. And then the complete one. And it will allow you to, basically it will require several passes. All Surf documents will also be Turf documents. But Turf is going to have a lot more features, such as a header that allows you to have metadata about the document. You're going to be able to specify a label here for an object and then add more properties to the object later, things like that. You'll be able to describe actual type names or just instances of those types. So the point of Surf is to make it simple as possible, to look as simple as we can get to JSON, but bring in all the features that we've been missing because we've been using JSON, and get people using it. So that the way it's written, it's not hard to make a parser. The reference implementation is a handwritten parser, and you can just basically, if you want to write implement another language, just bring look at the Java version and implement it. Just looking at it side by side, it's going to be straightforward. Yeah.
Aren't you setting yourself up maybe here for collisions? Like, how does it know that Doe is a player? You could have another array, and if you were just putting your IDs as these labels, there's nothing to guarantee uniqueness. So you could easily be pointing, you might think you're pointing at one from this array, but you might be pointing one from another array.
Yeah, the Surf specification being simple, it does not have any schema processing or type checking. Just like in JSON, you can point to anything. But when we start talking about the schemas, it's another layer on top of it. Then you can specify some of that stuff. But that's a layer on top of Surf. So yeah, you can make a winner reference. You can put Doe on a deer, a female deer. Glad somebody got that. Ray dropped the well in the sun. And so you could have doe pointing to a deer accidentally instead of a player.
So the so not your schema, but something else that builds the document is going to make sure that it's something consistent.
Yeah, there will be ways, as
Like
we'll get to in a
validations
second,
or something.
yeah, there will be ways as well to specify another document that this can only have values of this, but that's like the schema layer, which we'll talk about in a second. And George.
So, following up on what you just said, there isn't a possibility of treating the reference as a form of an XPath?
You mean to find something in your document?
Well, I'm just saying that doe, in this case, happens to be a child of players, which happens to be a child of game,
Yeah.
so that you could more uniquely qualify it if you wanted to, while maintaining the key for the definition is short.
I think that would be right now these are simply references linking a name up, irregardless of structure, with the caveat that it has to have already been serialized in the document. There could be an entire, addendum to serve for another separate feature that is like XPath that allows us to, because this in itself has a lot of other users, not just referencing. We sometimes may want to reference a location just like we do in XML. We want to say, give me the third player in the game with this ID or something. So being able to reference objects inside that document externally, like XPath, I think does have value. But
Probably
it
doesn't belong to the document.
What's that?
Probably doesn't belong to
Yeah,
the
I'm
document.
thinking, I don't think it's something to be part of the document itself. That's something to like peer into the document and say, it's like a selector in CSS. Here's how I look for things.
Right, but if you think about it, you can reach into the DOM before it's finished building.
Why?
Well, it's not a function of why, it's a function that it exists and people use it.
Why not?
Yeah, exactly.
The fact
That's not
you
why.
can do that doesn't mean you should.
But almost everybody does that as part of the loading before the load is finished.
All right, beer talk.
Yeah. So, by the way, so that's a great topic. The answer to the question is that Surf does not support that and does not envision that for simple object linking, but there is utility that, and it is something for beers.
Labels, are they unique throughout the whole entire document?
Yeah.
So
Well,
they
you can
can't
answer that
have
too.
doe twice, right?
Yeah, you cannot assign Doe to two
So
things.
if you use a unique label for all your objects, you should be able to reference that and distinguish one from the
Yeah,
other.
and you pick them up. So if you've got just a general serializer,
Okay.
it can come up with just random things, because this is not part of the data model, it's just a way to link them up. Dan?
Yeah, white space, and these references, is it ignored or what happens?
There's very specific rules in the specification. You can put white space in there. So between Doe and the star, you can put it if you like to space them out. So I envision there will be formatters for Eclipse or Atom Editor.
What
or
about
whatever.
a reference label? Can Doe have white space? Can be D?
Currently cannot.
Okay.
With the reasoning, and again, all these things, I've sat and drank and thought a lot, not all these, but a lot of. The idea here is that it's like sort of like a string. You don't have white space in between the delimiters of a string, the quotation marks. You can argue both ways. Currently, it does not allow white space in the label. Yeah.
Triple quotes for the multi-line strings.
I'm sorry?
Triple quotes for the multi-line strings.
Oh, I knew somebody was going to. That is a big question I want to talk about, because the big thing you have with those is multi-line strings. We got to be careful. I want to be careful. I don't want to gold plate Surf so much that nobody uses it, because you keep throwing stuff in, the parse becomes really hard, and it's like, okay, we've already got JavaScript, so so it's the bigger thing is multi-line strings, and triple single quotes. It is very useful.
Yes.
We do, And I would probably say I would pick a single thing. So that might be a thing I say only in turf. But I don't know. It's I don't know how many beers we're at this, but no, that is a completely valid question, and that is something I don't have an answer
You
for.
add it, I'll buy you a beer.
Do I have to implement it, or does that add to the specification? But yeah, so anyway, so I'm at the edge of a precipice. I can't even say the word precipice, whatever, a cliff. You know, where it's so simple, but I need some more stuff, and it's like, oh, it's got everything I need, but you know, we've fallen off the cliff, and it's so hard to write a parser for. So, I have to decide. Now, here's something interesting. Well, those things the labels I showed you, just a name, those are thrown away, and they're only a means of linking things up within the document. However, if you remember our user, let's go back here. Yeah, we put a GUID here as their ID, and we just have to remember that was their ID. Now there are a lot of things, you know, out of a database, so on and so forth, that those things are like their permanent ID. We have, especially semantic frameworks, they say we want to be able to identify this thing, and a URI will always identify the same thing. So sometimes we use GUIDs for that. You wouldn't want to assign a GUID to two different things, right? And a lot of things have URIs that specifically identify them. Web pages is the easy example, right? A URI to a web page, that's its identifier. Well, if you have a permanent identifier for an object, and I promise we're stopping with the features of Surf. I don't want to make it too complicated here, but if you put a URI inside that label instead of a string, this now becomes that object's permanent identifier, even after you parse it out. So you get that object back, you can say object, what's your type? And it will say user. You can say, give me your properties. It's going to say, here's my name, my email. Do you have an ID? And it's going to say, yeah, it's this URI right here. So suddenly your objects can have an identifier that escape the document from one point to the other. So, for example, if we have a user Jane Doe in this document, we have another document that has some more information about Jane Doe. It can reference Jane Doe. Now we can do this in any format right now if we remember what properties mean, whatever. But in Surf, putting a label with a URI before the object says I'm going to assign that URI permanently to that object. Now, if anybody's ever used RDF, which supposedly was the new semantic representation for the web, it was Tim Berners-Lee's newest child back in 96 or 8 or so, 99, somewhere in there. Everything in RDF, what I'm saying here is not new, I did not invent this. Everything in RDF is assigned a URI. Anything you can describe. Now the reason this becomes important, so we'll get to it in a second, is when you want to describe things later in a semantic way, make proposition assertions about things, like this shoe is blue. Which shoe? Well, you could say so before we were saying some user, right here, some user has a name of Jane Doe. Which user? Well, this user here that's in the document. There's no way to universally say which user. But if there's some database giving an ID to Jane Doe, Surf allows you to say this is the permanent identifier for Jane Doe, and you know when you parse this in what the identifier for that object is. It's very similar, if you haven't talked about semantic frameworks before, if you haven't studied them before, it's very similar to primary keys in databases. You can sort of think it like that, except it goes beyond the database. It's forever the primary key of this thing.
Does this mean that this is a feature that's baked into the parser? Like, will
It is.
Work, so it'll work out if I like have multiple objects with the same
Yes. However, though, you can use them as references in the document just as you did the labels. So if you got, let's say, anonymous objects that don't have IDs, you can throw in just a label in there, use it just within the document. But if you've got the an actual URI, we call these global labels as opposed to local labels. If you got a better name than we know, then you can use those for references as well. So you notice we don't even have to have this property of a GUID anymore. One last little shortcut. Remember how you did a GUID with a little ampersand sign? Well, this is a URI. It has to be a URI for the global label. However, there's a known standard for, it's a URI namespace called UUID for representing GUIDs in the URI. So if you put a GUID inside a URI delimiters, the parser will automatically know that you meant this thing here. It's just a shortcut. You see what I did there? See, the brackets are a URI, and then the ampersand is a GUID. And so if you put a GUID instead of a URI, it'll turn it into a GUID URI. Just a shortcut, and it looks prettier. Means exactly the same thing.
So if this user were to come out as an object in Java, would there be extra ID property that would return this string GUID? Would it be the hash code or some other thing? How does this?
So basically, according to the specification, the parser has to give you back something that says, I can ask, is there an ID and what is it? Separate from the properties. It is not a property. So if I were to list all the properties of user, it would say here's the name, the email. The ID is a separate thing baked into that object.
So this is the first form of metadata?
Yeah, and if you think about this, actually, it's all metadata. This thing is a user, and here's a list of properties about that user. So if you think about it, let's go back to, for example, an HTML page. The meta tags, it says author, and Garrett Wilson, translator, Magno Nascimento, who's my student who translated some of my lessons into Portuguese. Those are properties with values, but they're describing what? They're describing that web page. So I could do this exact same thing here. I could say star web page. Let me just do that. I don't know if this is really tiny small. Can you sort of see that? Maybe I should use Atom. Atom, I have a love-hate relationship with it. Good, it didn't bring anything too incriminating up. It's just, I was working here on this presentation in the coffee shop. That should be bigger. So I could say, so this is exactly to the real-life application. And we're going to a problem that's 15 years old, right? Those meta tags have been in HTML since HTML4 or before, right? So you guys know what I'm talking about, right? I've got a meta, name equals, you guys have seen these at the top of HTML pages inside there? It's simply, well, so I can say this in Surf. I can say a web page, it's the type, I'm just going to show it's a web page on a cow. Author equals Garrett Wilson. Translator. For example. But now you say, which web page? Well, funny you should ask that. This web page has a URI identified in it, right? So this happens to be the web page identified. For example. So this is metadata. Surf is metadata. It's not just a syntax. It's actually a semantic framework. And so right now I said, there's a web page. It's identified by this URI. Its author is Garrett Wilson, and its translator is Magno Nascimento. If anybody's worked with RDF at all, be looking at this and say, okay, they were saying this 10 years ago. So I'm not. This is not invention of mine. In fact, the initial impetus or motivation for Surf was actually creating a better RDF. So the semantic framework underlying it came first. So even though it's almost as simple as JSON, It actually is very extensive in its metadata describing capabilities. Yeah,
So it's,
Eric.
if it's all metadata, why didn't you call it simple metadata uniform resource framework?
Smart.
Because, because I had the ERF domain. That was part of it. ERF came first before there was a surf. The ERF, and there's some, actually, and we'll talk later about in Arabic and there's, I think in some, there's actually meaning to the word ERF, and I think in some dialects of Arabic, but we can talk about that over later on. So that ERF has some meaning as well, but there's lots of, it was short and I did have the domain. All right, I'm going to get into some, so like I said, you can reference the labels. What was your name again?
Constantine.
What's that?
Constantine.
Constantine, okay.
Back to that page, and back to my previous question, with the web page example.
Oh, okay. Yeah.
So that is not URI because the content of the page changes over time. So it's missing the version or the true identity of unchangeable thing.
Yeah, so there's actually a semantic web group on the W3C, and they have a mailing list where they spend days and days talking about exactly what you're talking about.
It's not
So it's like a
about web pages,
immutability
but
or not?
early we discussed the schema evolution.
Yeah. Well, so to some extent, you're talking about metadata of metadata. So you can say, and in semantic property frameworks, again, you can go on, they talk about this for days and days. There's people who are smarter than I am and who have more education than I am, but the specification they came up with, I don't think it's quite as simple as what I came up with. So,
Well,
but the point is that you can actually have in semantic frameworks even more assertions about these things. So not only the version, you can say, John Doe says that this is true. So you don't assert this proposition. You actually assert that somebody says this proposition.
what I'm alluding to,
It's called reification.
all the useful formats, be that YAML or anything,
Yeah,
they usually have a version. They-
yeah.
Let's say, okay, this is, let's say, Kubernetes.
So you're just talking about the document version as well.
Well, schema version, not the document version,
Document format version.
or format version.
Okay. Well, what I would say that the current idea is that versioning aspects or the metadata of the document itself, when Search started out, it actually had a header where you could put metadata about the document. For example, you would have a property that wouldn't be talking about the web page, but it's talking about this description of the web page, which is exactly what you're talking about. At the end, I think that was too complicated for Surf. So that is something that is supported by Turf. So you will have a header, you can have versions, you can say who authored this. For example, this says the author of this web page is Garrett, but it doesn't say who created this Surf document, right? So you will have those sort of things in Turf, but I thought it crossed that threshold of being too complicated. The purpose of Surf is to replace the primary uses of JSON. A quick and easy, but semantically rigorous and type-rich format to communicate between websites, between client and server, and also to use for configuration files. That's another good use. Long-term storage and versioning, things like that, I would suggest encouraging you to finish Turf. But Turf will address those things. Somebody else had a question?
Well, I was just going, I think, reiterate what Constantine is saying, is that one of the problems with JSON that we've experienced is that when you're doing an HTTP request, you have extra payload that you could put the versioning in and the path and all this stuff. But
And
when
what do you use for that?
Well, it depends. There's 2 or 3 different approaches for versioning, whether you can put it in the path Whether you
Okay.
put it in headers or
On
something.
the HTTP headers, yeah.
Or in the accepts field, right? But the point is that as soon as you leave a transport mechanism that actually has extra metadata, you suddenly no longer have any mechanism in the
Yeah.
actual format of the transfer definition there to carry across something that actually would change which instance this thing gets bound to or something
Yeah.
like that.
No, I completely agree. It's simply a decision if, pardon me, if we want to go down that road for surf, is that going to impede its implementation, impede its use because it's so, with SGML, you had to get XML and because it was so complicated to implement, to understand. The balance in my mind that I come up with right now is that it's not in surf, but those features will be in turf, which is a superset of surf. So if somebody needs them that much, they can, instead of shipping surf, text surf, they'll simply ship text/earth, which is the turf format. So it's a superset content.
Wouldn't be that kind of easy to add the metadata to, let's say, the web page as it's a metadata about the object. Just add the version there as a label and just
Because
done is that.
if it were only a syntax, but it's not. Well, it's not that easy. So more beer conversation. I don't want to spend all night on this, but no, I want to talk a little bit about why. A couple things about names real quick. And I think I need to go a little quicker because we're about time up, huh? So what I'm going to do, I'm going to go through these quickly so fast that only if you care about them, you might see a couple of these. The surf names, you can put a hyphen in front of them, and that represents namespaces. But not all this XML namespace where you have to define URIs and stuff. It understands that automatically. However, you don't have to worry about it. That's an extra feature. You can consider the surf identifiers as simply as strings. I'm going to. So there's a whole section here talking about exactly what you're saying. Let me go through it in like 3 minutes, just to give you an idea that this is included. So as I mentioned, everything in surf is a resource. Well, it turns out that these types, are resources as well. Just like in Java, a class is an object. It's an instance of type class. If you get into reflection and such. These properties are actually resources as well. In fact, even string literals are resources. Every resource is identified by an IRI. So it turns out, you've already seen how I can identify these resources. Now, by the way, everything I'm talking about now, you don't have to think about this to use surf. I'm just simply saying it's part of the underlying data model if you were to process it with an ERF processor. It turns out that you already know how to assign a URI to an object. Well, remember that we said that the type is a resource as well. It also has a URI. It's formed by the components of the name in front of, relative to an IRI ERF.name / whatever your name is. The beauty of this is that on the ERF level, again, you don't need to know anything about this to use surf. On the next level, you can identify any of those things, such as the types, the properties, and say things about them. Again, I didn't invent any of these things. They say the same thing in RDF, except I have fewer inconsistencies than RDF does. So now that we can name the property, identify the property, in fact, even literals, they have URIs that represent them. So the string foobar, it's actually this URI here. It's in the ERF.name. It's because it's type ERF string. So it's this URI with the hashtag with the lexical representation of the string beyond it. So we can even identify and say things about the string foobar. Again, you don't need to know or even care about this to use surf as a better JSON. I'm simply pointing out that there's an underlying semantic framework that's built on. It's not just a syntax that's thrown together. So you can describe any resource. You've already seen how you can describe the user Jane Doe. Well, you can also describe, for example, a property called crypto salt, as opposed to a chemistry salt, right? There's chemistry salts like monosodium glutamate or whatever it is, and there's also cryptography salts that you put in to make your hash functions better. So we can describe this crypto salt property and say it's an instance of an Earth property. Here's its description. Its domain, now back to I think Nick's question and Constantine's question, we can say the domain of this crypto salt property is any resource, and its range is binary. So it expects to have a value that's a binary value. And again, this is stuff you can find in any semantic framework, but there's no semantic framework under JSON. There's no semantic framework under XML, even though they created an object model for it later. In Turf, you'll be able to do it even simpler. So there's no schema for Surf. What you'll do is you'll simply define an ontology saying, I'm describing these properties, just the same thing. I'm describing the components that you're using to describe objects in the real world. Well, the properties, the types are themselves things that you can describe. So here's an example. I won't go into that because we've got it. So winding down, do I have maybe 5-7 more minutes? Okay.
Yeah, sure.
This is the end. I just want to tell you, as of just literally hours ago, there's one reference. So this is the answer to your question, Nick. There is one reference implementation that was finished just a couple of days ago. It was actually pushed to Maven this morning, and we've got the source code to it. It's on Jira. It's on Maven now. It's written in Java. There is actually a parser and a serializer. So just put this in your Maven project, or your Maven POM, io.earth, surf parser, and it's linked on the website. If you go to earth.io/surf, it's on the reference implementation page, all the links to Maven and everything. So you can try this out this evening. You can take that file that we saw earlier, and here's basically you import your parser. You say new surf parser. Using the new Java I/O stuff, you get a path to that file, and you open an input stream. That's all normal stuff. The highlighted stuff is the interesting bits. We say parser.parse, and it gives us what? It's going to give us either optional empty, the reference implementations in Java 8. Empty if the file was empty. If it was a surf literal, it's going to give you a value object, such as an integer, such as a telephone number instance, things like that. If it was a collection type, you're actually going to get an instance of set, or list, or map. And if it was an object, you're going to get an instance of something called a surf object. And the surf object, you can query it. You can say, do you have an IRI? And it's going to give you an optional that has an IRI or not. You can say, give me a property value. It's like a map. You can say, give me the property value for this, and it uses optional. So here, the beauty though is that you no longer have to parse your dates out of strings. They're already there for you. So here's an example, an actual example, using lambdas and such. I ask for the user joined property, and if it's present, I calculate the number of days between now and that join date, which happened to be a local date. It automatically gets parsed into a Java local date. The other part of the reference implementation is the serializer. Here's what you include in your POM. You include the parser and the serializer both in your, you import them into your program. And it's even simpler. You can create a surf object. You can give it a URI if you want. You can give it a type if you want, or you can just create it just as you would in JSON, a typeless, identityless object. Set its property values, except you can give them dates and string and telephone numbers, GUIDs and such. And then you create a new serializer and serialize to an output stream. It's as easy as that. Round tripping should work. It's a few things I didn't get labels done in time. And the shortcut URI syntax where you put a GUID inside the URI, I forgot to do that in time. But otherwise, it's 0.1.0 with the reference implementation. This is continually going to be added. Use cases. A lot of you are not going to go home and use this as a replacement for JSON and web services. Why? Well, because you communicate with other people and it's not yet available in Angular, it's not yet available in Python. You got to communicate with these things. However, you still have to use some sort of configuration files. So what you might want to do is try this out with a configuration file. A lot of stuff you put in a configuration file, you need, a date is a good example. You don't want to have to pull it out and parse that out in a configuration file. A lot of applications need configurations. One of the best, even though it's a bit complicated, and widespread packages for doing configurations is the Apache Commons configuration library, which just went to version 2. Well, we just now, in fact, you're going to have to see, as of, this went up like 2.5 hours ago, and let's see if it's on Maven yet. There it is, boom, it's up there. It was, I literally uploaded this too, because my developer Magno, he wrote this last week, did a great job on it. So all you do is included in your, anybody here use Apache Commons configuration for their configuration files? Well, you could try out 2 things then. Maybe just use property files, I don't know. But a bunch of the stuff here is just the boilerplate you need for Apache. The important thing is that you simply say that you're going to use the surf configuration class, which comes in that package I just showed you. And then all you got to do is say, config get me last login. And I know it's going to be a local date. So your configuration files, suddenly they're type rich. So this is one way you might want to try out surf. If you're not tomorrow going to replace JSON talking to your websites, you might want to at least try it out, something that's localized for your configuration files. It gives you all these new types and some new features.
I have a question. When you say, I know it's going to be a local date, how do you know it's going to be a local date?
Well, because that's what you put in your configuration file. When you serialized it, well, if you don't know that, when it comes back, you can use the normal Java, because we don't have any sort of schemas yet. So, if you were using XML, you would have to have some sort of XML schema to
I thought that one of the beauties of a date thing is it can be anything. So anybody can send you a date, but they're defining what that date is by that @ syntax that you have. So somebody could give you one format of a date, and then somebody can give you another format of a date, and you'd be able to parse it because you know how to do that, or no?
No, there's different types of things. So there's not different serializations for a date. Those different serializations you saw, and to understand this, you'll have to look more into the intricacies of ISO 8601 and Matt can talk about this definitely. There's different types of dates that we talk about. We can talk about what Java calls an instant, with the new time library for Java, which was modeled off of Jota time, which they did a pretty good job because they had several tries at it, right? So we can talk about an instant of time that's irrespective of time zones. It's simply a certain time something happened on Earth. We can talk about a particular date without regard to a time. We can talk about a date at a time, but without regard to a time zone. Or we can talk about a certain date and time with an offset of a time zone. We can talk about a particular year without regard to the month. So these are different types of, sometimes we talk about, dates. Well, dates is only what we talk about in Java, the old date thing. That's an instant in time, in computer time. That's only one of many types of dates. And so it doesn't mean they're all interchangeable, they're not. The beauty of the Java time library with Java 8 is that with all the experience with Jota time, they came up with a good model based on ISO 8601 to represent the distinctions between because time is difficult to deal with. So the local date here that I'm talking about, in your configuration, you knew that you were representing the joined time, you want to represent for example, the year, month, and day they joined without regard to the time or the time zone in which they joined, for instance. So I'm not saying surf will somehow magically convert from a time zone fixed instant to a local month and day. It won't. That's built in the Java library. What you will do is you'll get, what I'm saying is surf will semantically keep the fact that you represented a local date. And once you get it back, if you want to then assign a time zone to it and convert that to an instant using the Java time library, you can. Does that make sense? Time is a complicated subject. Eric.
So you have a parser and a serializer. Do you plan to provide an object mapper too?
Woo! Yeah, I'd love to. In fact, no, it's funny you mentioned that. I've started a project years ago called PLOOP, the Programming Language Object-Oriented Persistence. That's built on Earth that does exactly that. It's sort of like an ORM, a real-time framework for grenades. It's nowhere close to being finished. And right now I have my hands full and my students and whoever I can get to help me writing syntax highlighters, Python parsers, and so that will be a while before I get to that. Oh, so the next surf implementations you can see, I want this to succeed again. I've been working on this for 10 years, so I'm not going to give up tomorrow. I'm going to create JavaScript implementation of the parsers and serializers, have tools in Atom and Prism highlighters for the web, for example. Talking to Matt, I'm trying to convince Matt to convince somebody else to maybe get this in some format. And so these are the next steps. The current step is a reference implementation in Java that is available, and an implementation for Apache Commons configuration to using the reference implementation to load configuration files to play with. Last slide, more information. You can go to the website, earth.io, and the actual surf format page is /surf because this is going to be the site for the whole Earth framework. And again, if you have any questions, you can contact me at info@globalmentor.com. I left plenty of stuff for beers, the whole section of semantics. Any questions before the beers?
Little one, if you could go back like 3 slides, sorry, where you're actually, one before that. Yes. So yes, surf denoted that with the @ sign that the value is a date, and yes, you could look at that and say there's no time portion, so that's a local date. But you still had to write that I wanted a local date here. So why is this any better than just taking the string and parsing it? Like I could take a string containing that and say local date parse. Like what extra am I getting? Am I getting validation? Am I getting, like, are you preventing me from having invalidates?
So, well, one way to say that question, which gives one of the answers, is you're saying, so what is the value in, so I could have parsed it myself. So what is the value of me not parsing it myself? That, in some ways, is its own answer. You didn't have to parse it yourself.
I still have to specify local dates. I mean, at a certain point, I have to assign to a variable that is times.
Yeah, now, as far as programming errors in time spent in programming errors is really knowing that you were expecting a local date. Is that anywhere near the level of having to write a parser? And on top of that, when you share this with another language, making sure, as we say in Portuguese, fulano, that's just the way St. John Smith is like, fulano, this guy around the block, make sure he wrote his parser. I'll give you an example. This is, I did, for one of my clients, this is just 3 or 4 weeks ago, we were interfacing with a guy using Python. I wrote this great thing using the Java time library, and I sent all my stuff to him, and using ISO 8601 timestamps. This is a real story, it happened 3 to 4 weeks ago. And he parsed on, and suddenly all the stuff that was showing up in the database, because the user interface is an Angular, and it's stored with a JAX-RS RESTful interface, and then he pulls it from Python, puts it in the database. They were ending up, for some reason, 7 hours wrong. Yeah? Well, the library he used in Python to parse his ISO 86, the default one in Python, it's not so good at ISO 8601, and it decides to parse timestamps using the local time zone. So that, I think, answers the question. With surf, you're guaranteed across the board. You don't have to think about it. You don't have to write it. You don't have to see it. If you have a surf parser, it will support it and give it back to you. That's the answer.
Yeah.
Any questions? Other questions?
All right, thanks, Garrett.